Hi everyone. Today we are going to solve the resistance reduction techniques part 3. So see here, this is the problem given to us and he is asking us in this problem find the total current I. So how to solve this problem? Let's try to understand. So here we go. You can see this is node 1, this is node 2 and this is node 3, and he has been given that this is A, this is B, this is C, this is D, and this is E. So A, B, D are connected in delta form. So here we are going to get one resistor between A to B, and you see here this is an delta connected system. Okay, so we need an star connected system like this. So this is our star connected system. So this is one element and this is another element and this is another element connected between C and D, continued with 2 ohm and continued with 2 ohm. So this is a 2 ohm resistor and this is also a 2 ohm resistor, and it is closed now and it is excited with a voltage of 10 volts. So this is a 1 ohm resistor and we need to find out this red color one for the given black color one. You can see here how to find this one is this red color one is connected between these two parallel branches. So how to find? So 2 into 2 divided by 2 plus 2 plus 2 plus 2 plus 3. Okay. So when you solve it, you are going to get this value as a 0.5714 ohms. This is 0.5714 ohms. So when you are finding this element, so this branch is connected between these two branches, which is 2 into 3 divided by 2 plus 3 plus 2. So when you perform it, you are going to get this value as a 0.857 ohms. This is 0.857 ohms. So and next coming to this value is nothing but this resistor. How to find this resistor value? So this can be find. So we are converting this delta to star. This can be find. We want to center resistor is nothing but 2 into 3 divided by 2 plus 3 plus 2 plus 3 plus 2. It's nothing but again 6, which is nothing but 0 point same 0.857 ohms. So here also you are going to get as 0.857 ohms. And you see here we need to find the total current. It's very simple to do it. So I'm redrawing the circuit. Here you can see here the current flows like this and the current flows like this. You can say that the current is constant. These two branches are connected in series. So I'm going to get one resultant connected to this point, and these two elements are also connected in series. I'll get one element here and I'll get one element here, and I'm going to close the loop and I'm going to excite with some 10 volts as per the given problem. So when you add this 1 ohm and 0.57, you are going to get the value of 1.5714 ohms, and you see here this is of 0.8 and this is of 2, then you are going to get 2.857. I can say that these two are connected in series connection. Why? Because the current is same and these two are also connected in series connection. Therefore the sum is 2 plus 0.2, which is again 2.857 ohms. So when you solve it, you are going to get this as a 1.571 ohm and two resistors of equal value. When you do it, product, I mean 2.857 into 2.857 divided by some 2.857 plus 2.857. When you do it, you're going to get this as a 1.4285 ohms. So this you are going to exit. See here the current starts flowing like this between these two branches, and I can say these two branches are once again connected in which connection? Series connection. Therefore the resultant will be a single resistor with voltage source of 10 volts, and coming to the current, both are connected in series. Therefore you are going to get this value as approximately 3 ohms. So I want to find the current here. So how to find the current? Already you can see here I am redrawing it. So I have a voltage source of 10 volts, and I need to find out the resistance of equivalent is 3 ohm, and I want to find the current I of the network. What is the voltage at this point? 10 volts. And what is the voltage at this point? 0 volts. I want to find current is entering terminal is positive, leaving terminal is negative. So how to write down the apply KVL? Apply Kirchhoff's current law or apply nodal analysis. So I can write down this current I is equal to, so the current is leaving. What is the leaving polarity of the voltage? High potential minus, okay, what is the low potential? 0 divided by equal V by R. What is the value of R? 3 ohms. So 3 ones are, it's nothing but you are going to get the current as 3.33 amperes. So this is the resultant solution what we need. So let's try to recall the things. So this network is similar to that of an a delta network. The 2, 2, 3 are connected like an delta network. We transform the delta to an star network. We got these three values, and after converting as per the given formula, so you can see these two are in series, I drawn a single resistor. These two are in again series, I drawn a single resistor. These two are in series, I drawn a single resistor. After drawing, these two are in connected in which connection? Parallel connection. I drawn a single resistor, and already this is also there. After redrawing, this resistor and this resistor are connected in series. So I got the resultant resistance as 3 ohm, and I applied the nodal analysis and I determined the current as some 3.3 amperes. This is how to solve the problems by resistance reduction method. Let us try to solve one problem by using same method, resistance reduction method. Find the source current I of the network shown below. So the problem given is on bridge network. So I am redrawing the circuit. So the network given to is like this. This is a 2-volt source, and you have an resistor like this. The elements are 5 ohm, 5 ohm, 5 ohm. This is of 2 ohm, and this is of 3 ohm. So this is connected to this point. So now we need to find out the total source current IS for the problem shown below. So how to find it? Let's see here. Let's try to redraw it. So the nodes I'm going to mark it as A. Here this node I'm going to mark it as B, and this node I'm going to mark as some C, and this node I'm going to mark as some D. So between A, B, D, I'm redrawing the network. So this is A, this is B, and this is D. So the given network is an equal resistance and they are connected in delta. So we need to find out the equivalent star. So how to find the star? So we are trying to find the star. So I want going to replace like this, shall act as a neutral, and this branch also as a neutral, and this branch. So here I'm going to get the black colored what I required, one more branch, and this is one more branch, and this will act as a neutral. So I want to find out this will be continued with a 2 ohm resistor, and this will be continued with an a 3 ohm resistor, and we are exciting this with a voltage source of 2 volts at this node. This node is a C point, and this is a 2 volt system, and we are going to find out the source current Is. So how to find the center branch resistor? Already we know the formula, and you can see here this is connected in a delta connected system. So the straightforward formula is so to find this black color resistor, what are the resistance which are connected to this black color resistor? This is nothing but 2 5 ohm divided by 5 plus 5 plus 5. So this is nothing but we are going to get as 1.66 ohm. So same formula is employed, 1.66 ohm. So here also same for this branch also, these two are connected in opposite. So to this black color resistor, this 5 ohm and this 5 ohm is connected in parallel. 5 into 5 divided by 5 plus 5 plus 5. Here also I am going to get as 1.66 ohm. So coming to this black color resistor, what are the elements connected? So 5 ohm and 5 ohm. So 5 into 5 divided by 5 plus 5 plus 5. So 25 divided by 15. When you perform, this is also 1.66. And we have an shortcut to solve it. When your network is given in delta, which are of r, then the branch we can find out is by dividing it with 3, where the resultant resistance each branch is of r by 3, and r by 3. So here given value as per the given problem is 5, and when you perform it 5 by 3, which is equal to 1.66 ohms, which is the same answer which reflects here. So this is the first step. Coming to the second step of solving. So I'm having an 2 volt source, and I have a top resistor, and you can see here these two resistors are connected in series connection. These two are again connected in series connection. So I can claim that this is connected in series connection. These two are also connected in series connection. So this is node A, and this is some N, and I am going to get one single resistor, which are connected to the point C. So this is C point, and I am joining here. So here these two are in series connection. So 2 plus 1.66, which is 3.66 ohm. This is 3 plus 1.66, which is 4.66 ohm. So when you solve it, this is 1.66 ohm. When you're trying to solve it, so you can see here again these two branches are connected in parallel. So I'm going to get a resistance like this, and one more resistor 1.66 ohms, and I'm going to get 1 point, and I'm going to redraw it. This is the C point excited with a voltage of 2 volts, and the parallel. So what is the parallel formula? 3.66 multiplied by 4.66 divided by 3.66 plus 4.66. When you perform it, you are going to get the resultant value as some 2 ohm. can see here, this is of 2 ohm, 2 ohm, and these are connected in series connection. Why? Because the current is entering, the current is not dividing. If there is no division of current, I can say these two branches are connected in series connection. So the resultant circuit will be equal to like this. Applied voltage of 2 volts, this is of 2 and this is of 1.6, are going to get as 3 point, we are going to get as 3.7 ohms or 3.66 ohms. So now I want the resultant current I. Actually we discussed the nodal analysis. Whenever the current is entering, this is positive, this is negative, and what is the voltage available at this node? 2 volts. So try to apply Kirchhoff's current law. So I can write down current I is equal to high potential. What is high potential point? Plus 2 minus 0 divided by R. R value is 3.7 volts, which is nothing but we are going to get 0.54 amperes. This is our answer. Hope you are able to understand. So the given top network, I am recalling the problem for a better understanding. The given is a delta network. You can use this delta network also, but my convenience I am using this. So the given network is a delta network. I am converting this delta network into an star network. So here the values are of equal values 5, 5, 5. When you convert delta to, when you convert this delta to star, the values are divided by 3. 5 by 3, which is 1.6, 1.6, 1.6, with values of 2 ohm and with values of 3 ohm. I can say this 1.6 branch and this branch are connected in series connection. This branch are also connected in series connection, and you have a resultant of 1.6 ohm. So this is 1.6 ohm, and these two series we have 3.6, and these two series we have 4.6. And once again these two branches are connected in parallel. I applied the parallel formula, and this parallel branch is in series with this branch. This 1.66 and this 2 ohm are once again in series connection. I got the resultant. So we are going to apply the nodal analysis to find the current I. I is equal to the, what is the current is leaving, what is the leaving polarity of the voltage? High potential minus low potential minus divided by resistor 3.7. So we are going to get the value of current as 0.5 ohm. This is how to solve a problem under resistance reduction. Let's try to go to the last model of having analysis. So if you solve more problems, you can get confidence and you can handle the problems in a better way for your understanding. So here one problem is given. Find the equivalent distance between the terminals R, X, Y. The circuit is given like this. This is X, and you have one resistor here, and you have one more resistor here, and you have one more resistor here, and this is shorted, and this is also shorted. This is Y. So this value is 1 ohm. This value is, sorry, this is not given. This is directly given as R is equal to 0, and this value given is 1 ohm. So is asking what is the distance between R, X, Y. Actually, as you understand the problem better, here you can see here. Let us try to mark here it is also X, here it is also Y, here is also Y. So whenever current always flows, current, we have the formula current I is equal to V by Z. Current always flow in low resistive path. Okay, so this always tries to flow when you have low resistive path. For example, you have one upstream like this, you have one resistor with 2 ohm, and you have one resistor with 0 ohm. Okay, when you make the water to flow, the current will come to this node and it will not flow in high resistive path, it will try to flow only in low resistive path. Okay, therefore the total current will flow only in this path. Why? Because this is offering as low as possible. The resistance offered is low. As the resistance offered is low, automatically the current will flow only in that direction. As per this concept is concerned, so you can see here, without solving, I am saying the value of x and y is r is equal to 0, where this is short circuited and the voltage is also 0. Let's try to verify whether our assumption is correct or not. So you can see here, this seems to be like a star connected network. So this is a star connected network. I want an delta network. So this is one delta, and this is another delta, and this is the another branch for the delta. So now x I have here, and this x I am constructing, and I am having one element like this, and here I have one more element, and here I have one more element. This is nothing but y. So now we need to find out these values, and already between these two, what is there? A short circuit is there. Between these two also a short circuit is there. So now I want to find this black relay resistor value. So this value I want to find out. This black is connected between this 1 ohm and 1 ohm. So the formula already we have in the previous session. The star can be converted into delta. So this black is connected between this resistor and this resistor. First write down 1 plus this resistor is 1, and the product of these two resistors, product is 1 into 1 divided by, so this resistor we are finding, what is the resistor in 90 degrees to this? 0. So by 0, so anything by 0 is nothing but infinity plus 1 plus infinity plus 1 is also equal to infinity. Total value is infinity. So here I am getting this value as infinity. If it is an infinity, automatically the current doesn't flows. Okay, so this is infinity. How to represent an infinity? Now coming to the second branch, so I want to find out this branch. So this branch, black color branch, is connected between 1 and 0. So I am going to write down 1 plus 0 plus product of these two, 1 into 0 divided by 1 into, what is the branch in 90 degrees to this? 1. Okay, so this is also 0, this is 0, and this is 1 ohm. So resultantly you got here as 1 ohm. Now come here, this value. So this black color resistor is connected, and what are the known values? 1 ohm and 0 ohm. So first value is 1 plus, what is this value? 0 plus 1 into 0 divided by, what is the resistor in 90 degrees to this? 1 by 1 ohm. It's nothing but 1. This already numerator is 0, 0, and resultant is how much? 1 ohm. So here we are going to get 1 ohm. But when you see this problem, when you see this problem, so between x is there, so current will start flowing to this node. So now current has to flow across this branch or this branch. Current always flows in low resistive path, it doesn't flows in this branch. Okay, so current will flow in this branch, and between x and this node, the current will not flow in one branch, it will flow in the short circuit path, and the current will come to this, and current has to flow in this path or this path. So current doesn't flows in high resistive path, current flows in only low resistive path. Okay, so the low resistive path is the short circuit path. So I'm going to draw the short circuit path. So I got the x value and y value, and this is the resistance rxy. So now we can see here there is no resistor connected between these 2 points. I can say that this branch is offering a resistor as 0, and since it is short circuited, current is short circuit current. V is equal to I short circuit into R. So I short circuit is some x amount of current, but the resistance value is 0. Therefore, when you are performing, whenever it is short circuited, resistance is 0, current is maximum, and voltage is 0. This is a condition what you are going to get. So already I told, Without solving the problem also we can solve it, yeah? You have better knowledge. So directly by seeing the problem, the current flows only in this path. The current doesn't flow in this resistor. Direct it will get diverted. Direct it will come to this point. At a direct it will flow. The current directly will flow in this path. So that's how we solve this problem. So hope you understood. This is a star connected system. We convert into an delta connected system, and this branch is acting like an open circuited. Whenever it is open circuited, the current flow is zero here. The current does not flow in this branch. The current will come here. Current will not flow in this branch. Automatic current will flow only in the short circuit path, and the current comes to here. And current doesn't flows in this resistive branch, and current flows in the short circuit path. So ultimately the current will start here and it will flow in the short circuit path and flows in short circuit path, and it will follow the loop and it will come out. So this is the direction of current. The same we represented here. The current flows through X, doesn't flows across 1 ohm. It reaches this point and it reaches this point and it travels like this. Therefore this is the all the problems we solve under resistance reduction. So if you solve all these models, you can have good confidence in solving all the problems, and you can have good knowledge to attempt the gate problems and the competitive exam problems. Hope if you feel that the lecture video is very useful to you, please like our channel, share the channel, and subscribe to the channel. The name of the channel is kvthulasi. So hope the lecture is very useful. So thank you for your valuable time. Thank you, viewers. Ram.